Well, welcome back to Advent of Code 2017, day 8. I heard you like registers. You receive a signal directly from the CPU because of your recent assistance with jump instructions. It would like you to compute the result of a series of unusual register instructions. Each instruction consists of several parts: the register to modify whether to increase or decrease that register's value, the amount by which to increase or decrease it, and a condition. If the condition fails, skip the instruction without modifying the register. The register all set at 0. Instructions look like this. Okay, these instructions will be processed as follows. A has 0. If it is not greater than 1, and so it is not greater than 1, and so B is not modified. Being 5, okay, A increased 1, B is less than 5, C is decreased by minus 10 to 10, because A is now greater than or equal to 1. After this process, the largest value in any register is 1. You might also encounter less than or equal to and not equal to. However, the CPU doesn't have the bandwidth to tell you what all the registers are named. So we have to figure that out. What's the largest value in any register after completing? Okay, so there's lots of different registers. Let's just handle this. Okay, now I can do this. File path, read lines. Get the input, which is the example input. Then I could delete this. We check the input. So we have, we just have this kind of weird mutable map of string to int, and then how do I add stuff? So, well, okay, I read the line by doing what I always do, split string with a space. The first one is the name. So usually if name in registers, then I can just, actually if it's not there, it doesn't matter, I can just do this anyway. And then I can do zero. And if I were to add 5, it would be plus 5. So let's find out what we need to do. When A1 is inc, then we need to increase. What options were there? Increase and decrease. Okay, there's only increase and decrease, and there's also if instruction. And there's always an if instruction, okay. So we just have to say if we increase, we would do something like this. And we increase by. a2 to int. And if a1 is decrease, we do the same, but we decrease minus x. And we only do this if condition is true, which is something we have to figure out. How to get the condition. So we have 0, 1, 2, 3, 4, 5, 6. So we have left a4, operator is a5, a6, condition depends on operator, if it's like this one, or it could be greater than equal, smaller than equal. Let me just say left. What's like the real input? I need to check. Well, the right side is always a number, it seems like. The left side is always an operator. Okay, that's cool. Then we can just say left or 0 is greater than. I mean, we can just do this here. Left is this. A4. Right is to int. And I can just do left greater than right. And I can do left smaller than right. And I can do left smaller than equal to right. And then else, error, operator, unknown, known. And then we can pull the operator out. No, I like looking at it. So based on the condition, which is a condition, we do this. Then okay. Then we just print the registers. Equals equals. Aha, this is my own custom. Perfect. And we can add it. Ah, yeah, that's also not equal. Okay. A is 1, C is minus 10. 1 is the largest. So we have to just get the largest, which is map max of. This is the largest. And we're off to part 2. To be safe, CPU also needs to know the highest value held in any register during this process so that it can decide how much memory to allocate to these operations. For example, in the above instructions, the highest value ever held was 10 in register C after the third. The highest ever. Okay, then we just do something like this. Result is 0. Then we check No, result is registers.max of, okay, there's like nothing there, so it's 0. And then anytime we do any registers, which is just here, after we did it, max of the value is higher than the result, then okay, potential max, then we set it to it, else we leave it as. And then the actual highest that we ever stumble upon is this one. And that's it for day 8. Okay, so we just basically implement the instructions for part 1, and for part 2 we keep track of whatever was the highest. So how do we do it? For each line, we split space, get the name of the register, get the left operation, which is always a register. So we take A4, which is the line split 4th, so this one, or 0 if the register doesn't have initialized yet. That's the left one. Then we have the operator, which is just 5, and then right is always an integer, so we can just get the string and cast to integer. Then we just map the operators 1 to 1. So if it's greater, we do greater. If it's greater equals, and so on. And then we also evaluate at the same time the condition. So if left is greater than right, or whatever we do evaluate, if that is true, then we go either increment or decrement the register in the place of name by the second number, this entry here. And once again, then we set the register at that name either by adding the value to the name, or if the register hasn't been initialized yet, we say it's 0 at the beginning and just add x into the register. And the same with decreasing. And yeah, that's how we get the largest register at the end, and then we keep track of count and the potential maximum of the register by checking every time after we maybe update something if there's a new one. If it's greater than the biggest we currently are keeping track of, then we update, otherwise it's the same. And that way at the end we have the largest number we came across in our process in this variable. That's it for day 8. Enjoy the rest of your day.